So we got a kind of interesting project going on here. Basically, we have our local snowmobile club, ADSC, our drag in here. It's a big piece of equipment. I don't know what this thing weighs, like maybe 5,000, 6,000 pounds kind of deal. But anyways, along the rails here, there used to be wear bars, and the wear bars have obviously done their job, and they've all worn away, way past what they should be. So, I mean, we could have sent this out as a club to get it refurbished, but we might have lost the drag and got a crappier one. So this is a really good drag. So what we're going to do basically is put on new wear bars. The way we're going to do this is, because we don't have a crane to lift this, so we just got slightly larger than this 2-inch material here. We got a 2.5-inch piece of material, and it's going to stick out a 1/4 inch on each side, which will allow me to weld down right into this material. This is really heavy kind of steel, so it should be pretty easy to do. And there's an awful lot of it. I mean, this thing is, I don't know how long it is, but we got the steel measured up. The steel cost was pretty inexpensive. It's a 1/2-inch plate by 2.5, all cut to these individual lengths here. So the steel, I think, was $360, $370. So for us to send this out, there's no way anyone could do it for that cost. So, and I have the equipment, the welder here. I got a Power MIG Lincoln Power MIG here that can easily weld that kind of plate steel. So that'll be the project that we're going to be doing here. Kind of interesting. All right, we're all ready today to add the new skid plates on the drag. So basically what we went with was 2.5-inch by 1/2-inch plate steel, cut to the appropriate sizes over there. What was on there originally was actually underneath it was a 2-inch piece of material here, 2-inch, but this thing is so heavy, we need a crane basically to lift it up to weld underneath it. So what we decided, we're just going to go with a little bit wider, and then we can just weld it on the edge, stitch weld it all along the edge, and this material should last quite a while as a wear bar skid plate. So it'll probably give the drag a tiny bit more float, but if it does, all of these little blades can be adjusted down slightly, so if it floats too much. But that's the plan for today. We're going to grind it all flat, and then tack weld, and then final weld on. The only modification to the steel that we're really going to do is I'm just bullnosing the ends of these just so it doesn't catch on the front of the drag, so just to round it off. Other than that, we're just going to use the steel as is. All right, so we're test fitting the material, and there's quite a bit of wear on this, so it won't be a problem all along there, but as you can see, the tip of this has worn away quite a bit. So what I'm doing, I'm just notching the metal, and then I'm going to tack it at the rear with good tacks, and then I'm basically going to take a jack and jack it up, and so that it'll bend to the conformity of the, it'll make like a little ski tip too. Not that it originally was like that, but the metal's just so worn. So that is the plan for that. Half the project is done. Basically, we're just stitch welding it all the way. We ran into a few problems. The material on the front and back was perforated all the way through, so we had to build it up with some scrap metal we had and just kind of bullnose it as best we could. I know it looks like a bit of a kludge fest, but the material there was really compromised. So, but overall, it's looking pretty good. And on the rear, it was all compromised too. So we added a little bit of material, but that 1/2-inch plate steel will definitely reinforce it.